Guys, today we're going to do Academic Chemistry, Chapter 4, Section 2, Part 2, Dalton's Atomic Theory. So we're going to go over the scientists that helped develop the concept of the atom, what they did, and we're going to break it up by each scientist. So this part will just talk about John Dalton. Now what I want you to keep in mind during all of these lessons is that we can't actually see the atom until super recently. And even at that level, we can't really see those subatomic particles. So the things that people are finding, we have to find kind of roundabout ways to figure it out. So sometimes they won't get the whole picture, but the next scientist will build on that. Now keep in mind, you've already seen the picture of the atom, or you have a structure in mind. So this is probably what you think of when you think of the atomic model. So this is like basically that picture you see on the Big Bang Theory. You know that there are protons, neutrons, and electrons. So you've already heard about those. But the scientists that we're going to talk about, they're going to talk about how they figured out those things. So let's go back in the day to John Dalton. So John Dalton first proposed his atomic theory in 1803. So that's over 200 years ago, which seems like a while ago, but for the whole human existence, just 200 years ago is when we really figured out the idea of atoms with science. And he thought of atoms as these simple, incredibly small balls of mass. That's all they were. You can kind of picture like a billiard ball, but at the atomic level. So atoms had specific properties and could combine in various ways, but he didn't think there was anything within the balls of masses. So he didn't think it could be divided up at all. He just thought that's it. Like how could anything possibly get any smaller? So, carbon atom, that's it. There's nothing inside. It just is that little circle of carbon or dihydrogen monoxide. Water, it's just those two hydrogens and that one oxygen. That's it. There's nothing inside each of those hydrogens or that oxygen. Or here might be a sodium chloride. It's one sodium, one chloride, nothing within the sodium, nothing within the chlorine. But it's really a limited model, but it's pretty good for the time, right? They couldn't see these things, so it's a good start. This is why we call Dalton's atomic theory the start of the modern atomic theory. So this was the real thing that got the ball rolling. Pun intended, because he thought they looked like little balls. At the time that Dalton was proposing that atoms even existed, some people didn't believe him. It took a lot of convincing. And one of the big experiments he did was he did the conservation of mass. And I mentioned this briefly before, but let's really go into it. So since mass was conserved, meaning the mass you have to begin with is the mass you have at the end, there must be something small that's rearranging itself in a chemical reaction. So here's some data that we can figure out. So when salicylic acid and acetic anhydride mix, when you have them react, then they make acetylsalicylic acid and acetic acid. This is actually what you do to make aspirin. If you have these masses of each of the reactant and each of the product, this is what you'll make. So if you notice, if you take the total mass of the reactants, you add that up, you get 240.21 grams. And if you take the total mass of the products, you get 240.21 grams, which means everything you had to start with is somewhere in everything you have to end with. So that's why he realized there has to be these small little pieces that they're breaking into and that are rearranging, because nothing's magically forming out of nothing, right? All the matter you have to start with is matter you have to end with, so it must be rearranging in some way. If it's rearranging in some way, it has to have pieces that make it up that are doing that rearranging. So at that point, though, you have to remember in Dalton's atomic theory, no one knew what these little balls of mass were made of. They just knew that they existed, and they were really small, and they combined in whole number ratios to make compounds. And that's it for Dalton's atomic theory. Like Dalton could have his mind an image of what, a pure sample of maybe sodium would look like. He might think it looks like this. Just they look like almost billiard balls, just lined up in a whole stack. And although that's true to a degree, it's not good enough for what we know now, because we know that the atoms, actually there are pieces that make it up from the inside. So going forward, we're going to talk about what makes up the atom and how scientists figured that out. So see you in the next video.